So in this one, let's talk about various places where you can cache things. We understand that hey, caching massively improves the performance. It comes with a cost of staleness, but it massively improves the performance of your system. So it is very tempting to cache at every single place that we can. So in this one, let's talk about different places in your architecture where you can cache things out. So the most common cache we saw was Redis. Almost everyone uses it. It is almost the de facto standard, but no biases towards it, but you should definitely know Redis. It has some amazing properties out there, right? But Redis stores data in memory. But that is not the only place where you can cache. Redis is not the only place where you can cache things out. Now here in this one, I'd like to probe you all into thinking on different pieces of your infrastructure where you are caching something, right? So first of all, warning that although caching is good, it comes with its own massive disadvantage of staleness and invalidation. So what happens is when you are caching something, so unless that key expires, you are serving the stale data, right? Because in your actual database, the value would have changed, but you are okay serving the stale data. So stale data is a problem in case you want always the most consistent, accurate, recent data, then you cannot cache things out. I'll give you a practical example. Bank account details, or rather bank account, your financial summary, right? If your current account balance, if they used to render it from the cache, let's say your friend said, hey, I made you a transaction, it's there in your account, and you open it, and because it is coming from cache, you see old value. Say, no, you did not send me any money, right? There are some things that you cannot serve from cache, no matter what, because there the recency is very important. You need the most consistent information, especially it comes to financial application. You need the most consistent information out there. So there you cannot work with stale data. So caching those things is not good, but you can still cache phone numbers and user details and basic other information, but some things you still cannot cache. Other thing is invalidation. As we saw that when you store something in cache, you can store with an expiry. Once the key expires, it gets auto deleted. Once it gets auto deleted, for the next request, it would be filled up again, right? But now, for example, what if you want to proactively populate or update the cache, like what we did with Cricket Score. If you want to proactively update it, it's called invalidation. You are marking that cache as invalidate. You are invalidating the cache, which means you are either deleting the key or you are updating the key with your new content. Now, both of them are challenged because you possibly can do both and none. It is very use case specific. At some use cases, you can go ahead and populate a cache right away. In some cases, you would explicitly ask it to delete the key, right? For example, if you cache something at a particular place and you know that record is updated, you can make a call to cache and ask it to delete that particular key. Right? That is invalidation. But staleness is a problem. So if you want fresh data, you cannot cache it. If you are okay with stale data, then you can cache it, so long as data is frequently accessed. Right? So let's talk about different layers in your infrastructure where you can cache things out. So first is client-side caching. Client-side caching is what your client holds. Client is connecting to your system typically from a browser or a mobile device. So what if you use the browser to cache something? What if you use mobile device to cache something? For example, what you can cache on the browser side is something which is near constant data, like images. When you load images in your browser typically caches that images. For example, logo of a particular website, your browser automatically caches the images that are requested. Next time when you open the page, it does not have to make a network call to load the image. It can right away render that image because your browser is caching it, right? So images is one. JS files, the JavaScript bundles that you have, why to fetch them over the network again and again? Just cache it on your browser so that when you load the website, it is immediately loaded. Rather than making a network call and reading that file and then applying it, you directly run that JavaScript file. Like your browser automatically caches that, helping you save that expensive network IO, right? User information, you may cache it, some basic information, profile, most recent post and whatnot. You can choose to cache that part. Amazon Prime Video caches what you saw most recently in your browser cache. This way, when you open Amazon Prime on your browser, you start from the point where you left off, right? So if you're watching in two different devices, you would see that difference. That if you're watching on other device, it would see, hey, you are watching this, but when you watch that other thing on your browser, you see some other thing, right? That's the problem, right? You don't get consistency because you are caching on the client side, but it gives you better experience, right? So you go for it. So long as you are okay with serving a bit of stale data, it's fine. You can cache it wherever you want. Especially client side gives you massive performance boost, right? Because you're not even making a request coming to your infra. You're just literally serving it right there and then. So for these things which are near static, some meta information, you can typically choose to cache it on the client side. And after the client, what comes in? There comes CDN. So let's spend some time understanding what CDN is, how it caches, and the kind of benefit it provides. So CDN are one of the most interesting places to cache things out. So CDN stands for Content Delivery Network. Now these are set of servers which are distributed across the world. It's not something that is just one region. CDNs are distributed across the world, and the idea is very interesting, that if a user from a particular geography makes a request, this request should go to the nearest CDN server. Simple. For example, I'll give an example. Let's say US folks are getting images from US server is much faster than fetching it from India. Basically, if let's say I am someone who is hosting a platform, and let's say I hosted that platform in India, right? I have bunch of files, bunch of content and whatnot that I am serving. If someone from the US is accessing what I have built, if my servers are in India, the request from US needs to travel to India and then response is sent back, right? Now this huge transatlantic ocean sort of communication is very time consuming, right? It needs to travel through massive distance to get it answered, right? What if I cache the information that is not really changing on CDN server, which is closer to US? So when the request is made from the US, it gets to the CDN of the US and immediately served from there. It's not business logic. It's again static files, images, basic images, JS bundles and whatnot. It's that same static content, but in order to even get that static content, why to even come to India? What if it gets served right there and then from US? This is the idea of CDN, right? CDN stands on this principle where a user, when it makes a request, it gets served for that static data, it gets served from the nearest location and not from the long, far, quote unquote, origin server. Now let's talk about origin server. So when you configure a CDN, what you have is, you say that, hey, this is my origin server. Origin server is where, if your CDN does not have the data, where should CDN make the request to? That is your origin server. So here what happens is, user makes a call to CDN. If CDN has the data, it serves it back. Brilliant, right? When I say CDN, it goes to the nearest CDN server, and that's the magic of CDN and how they route it, right? But user makes a call, it goes to the nearest CDN server. If it has the data, it serves it. If CDN does not have the data, CDN calls the origin server that you configure on the CDN. So when you configure a CDN, you specify that, hey, this is my origin server. So if you don't find anything, talk to this origin server, it would give you the data, right? For example, I'm loading an image. I gave the path of CDN, the request came to CDN. If CDN has the data, CDN serves it. If it does not have the data, CDN makes the same request to the origin server. Origin server sends the data, it caches it over here and sends a response back to the user. This is how it works. And you could very clearly see how CDN is doing lazy cache population. You are not eagerly pushing data to CDN. You can, but in most cases, the most basic configuration of CDN is always lazy population, where what you are doing is you are lazily populating the data in the CDN. So your request comes to CDN, CDN does not have it, it makes call to API, API sends the data, CDN caches it and then sends back to the user. Subsequent requests are all served from CDN. And like a normal cache server, CDN, when you cache something on CDN, there is an expiration set to that. After that expiration, the data is deleted automatically. The next request that comes in has to go to database, comes back to CDN and does that. So the call that comes when there is a cache miss on CDN is done by the CDN. You don't have to do anything. CDN transparently makes that call to the origin server, right? So now, a simple example to conclude what CDN is all about is where, let's say, if I'm hosting my server in Australia, let's say Sydney, right? And I've configured a CDN to in front of my infrastructure, right? So this is where my hosting is. In front of my infrastructure, I've configured a CDN. So CDN examples are Cloudflare, Akamai. These are very popular CDNs out there. So let's say I configured Cloudflare over here. In Cloudflare, what I configured is I configured this server as my origin server. Right? Now someone from India is accessing my product, which is hosted in Sydney. Now what would happen? The request from user, which is sitting in India, comes to Mumbai's CDN server automatically. Now that's the magic of CDN. How it gets the request to the nearest server is the magic of CDN. The request comes to Mumbai. If it has the data good enough, it serves it back. If it does not have the data, it goes to origin. Where's the origin? Sydney. It goes to Sydney, fires the same request, gets the response, caches it, and sends back to the user. Now here you see the request from user did go to Sydney, but via CDN. Because it went via CDN, the CDN was able to cache the response that it got. Now subsequent requests coming from anyone from India to this Mumbai server would not have to go to Sydney, but it would be directly served from the Mumbai server, minimizing the latency to the maximum. It's very close to anyone in India, very low latency. You get the best experience out there, right? Always remember this. So CDN is just a geographically distributed cache, which is lazily populated in general, right? You can still push data to CDN, but it's a very different way to do it. Won't go into those details, but understand this. The most common configuration that everyone configures CDN, 99.99% cases of CDN is lazy population. Exactly how I described, right? So what I would want you all to do is spend some time, go through Cloudflare and Akamai documentation. Try to configure a Cloudflare. You can create free account on Akamai and Cloudflare. Go there, play around with it. See what I was talking about. Try to configure a CDN. Go through YouTube tutorials on how to exactly navigate on their console and play around with it. Right? Instead of just building theoretical understanding of it, just play around with Cloudflare or Akamai. Pick your favorite, pick one at random, start with that. Right? You would have a time of your life exploring CDN console, seeing those different configurations, and you'll become better engineer. You'll actually understand how to leverage CDN for a certain use case. That's number one. Number two, go through their YouTube channels. Go through people talking about CDN and how they have leveraged. You're just a Google search away on how they actually configure a particular use case on those CDN. You'll learn a lot by actually doing it. Right? So that two things you should definitely try out when you're exploring CDNs. Right? Now the next one is remote cache. This is where we spent a lot of time in previous videos around talking about Redis. This is an actual remote cache. Remote cache, which means any cache that is remotely accessible. Centralized but remotely accessible by anyone within your infrastructure. That's typically your remote cache. So whatever we studied in a normal cache discussion in the previous things is exactly what this remote cache is all about. So a cache which is accessible by everyone in your private infrastructure over network is a remote cache. So the cache is not distributed, it is not decentralized, it is centralized but remote, which is accessible over network. Right? Now here, always remember, in almost all the caches, whenever you are caching something, you should always have some expiration set to it. Otherwise, it's a classic case of memory leak. Right? The size of cache is very small as compared to size of database, which means you possibly cannot cache the entire database in a cache, which means you have to be very frugal into what you are caching, how you are caching, and having an expiration on top of it. Right? Okay. One final thing I want to talk about is using database as a cache. A normal relational database will take as an example. Now this is slightly out of the box, but very fun example. So in a blogging application, user can publish multiple blogs. Now let's say in the profile information of that user, I want to showcase the total number of blogs that that particular person has written. Now a way to do this is, for every time I'm rendering the profile of that person, I make one query to database to get the information of the user and another query to go to post and count the number of posts made by that particular user. Now counting the number of posts made by particular user every time is an expensive query. Every time is an expensive query. So now what I can do to speed things up, I can actually in my users table itself, where I'm storing ID, name, and other fields, I can create a column called total post. In total post, I'm storing the actual count of the post. This is caching. I'm saving an expensive computation of my database by storing it in a pre-computed way. Now, what I want to do is whenever a post is published, I would eagerly go and do count plus plus over here. This is an eager population. So whenever I publish a post in that same database transaction, I would do update users, set total post equal to total post plus 1, where user ID equal to 1, 2, 3. With this eager population and doing it in a transaction, I'm able to save an expensive query which is fired from the database. Here I don't need to set any expression, but this is how I just made this thing redundant by creating a copy of this data. I'm not storing the actual post multiple times, but I'm just storing, pre-computing the count and keeping it updated whenever the post is published. This way, I save an expensive query that I was firing. This is also an example of caching. I'm caching the data sometime. I'm saving an expensive computation by storing the data pre-computed in my database and leveraging database transaction to keep them in sync. Where what I'm doing is whenever post is published, I'm also updating this count to total post equal to total post plus 1. Right? And this is one more example where you can use database as your cache. You are actually caching this information over here. You are not deleting anything, but you are saving an expensive computation. Right? Now, there are other places, whichever component that you see in any system that we design, literally every single place that you'll see, you can think of putting or storing some data in there which could be cached, right? But for example, one more example is load balancer. You can cache things on load balancer. Because we did not touch upon load balancer, so I refrained from talking about it. But literally every single component that you see in any system, it has memory, it has disk, which means you can cache something into it. But does not mean that you should. You can cache it, but does not mean you should, because the more layers of caching you add, the more staleness you are adding to your data. Why? Because now you have to go and invalidate every single one of them. And then only your data would be freshed. For example, if you cache something on your database and your centralized cache and your load balancer and your CDN and your client side. So now when something gets updated in the database, what you'd have to do? You would have to go and invalidate the database cache, then your remote cache, then your load balancer, maybe your API server, then maybe your CDN invalidation, and then your client side cache. It becomes very lengthy, right? And everyone might not give you APIs to do that, which means that pick your battles, because over caching things at every single layer is a pitfall. It's an anti-practice. You should never do that. If you do it, you be aware that you would have a massive staleness in your data. You'll have to take care of massive invalidation as well. However, invalidating things here and there, you have to take care of that, and that is a huge pain, right? So always remember, just because you can does not mean you should. Pick your battle, see where's the best place where you should cache it, and just cache at that place only. Don't unnecessarily cache at every single layer. It's futile. But you should know where you can cache it. Literally every single place where you have some RAM and some disk, think of it as a cache for yourself, because then you are saving that expensive downstream calls that you are making. You would save all of them, right? And that's all what I wanted to cover in this one. Thank you so much for watching. I hope you found it interesting. Hope you found it amusing. That's it for this one. I'll see you in the next one. Thanks a lot.